The following takes place on the day of maximum flat earther stupidity, between 10 a.m. and 11 a.m. Events occur in real time.
And so that's why you should never ever do anything like that while you're covered in warm caramel. Excuse me. Sensible. CFU.
Sensible.
Mr. President.
We have a real problem. Flat Earther Anthony Bear has got hold of some highly classified information. He has threatened to release it to the world.
What's the nature of the information? I'm going to need to know.
I'm uploading it to you now.
Thank you. It's coming in now, Mr. President.
If you cannot stop him, it will be the destruction of the great conspiracy. Science will be a laughing stock. The heliocentric model will be done for. Many golf scores will be way up. Many kittens will die. We have got to protect our phony baloney jobs.
Of course, Mr. President. What are we looking like for timescale?
You have until 11 a.m. Then it is all over.
Leave it with me, Mr. President. Right, let's have a look at what Anthony Bear has got.
Okay, let's talk about seasons on a globe. Now, we were taught this like when we were kids, right? So let's take a better look at it. Okay, here's our miniature globe model, and I'm going to show you how the seasons work. So this is our summertime where the globe is tilted towards the sun for the summer solstice. And we're going to be talking about Michigan, because Michigan's a nice moderate spot to use.
The target is Michigan. I want you to dispatch 2 TAC teams.
So now the Earth spins for days. That's how you get your day and night. And then at 3 months later, which would be about here, this is the equinox. So it's going to start getting colder because the angle is changing.
Retail satellites. I want total coverage.
And 3 months later, which would be 6 months later from the summer, now the Michigan's tipped away from the sun, and that's how you get wintertime.
Open a socket to the server. Free up memory. We're going to need it.
Okay, in this video, we're going to be talking about Michigan. And if it's possible, the angle of the Earth is going to make that type of difference in temperature from the winter to summer. Okay, so here's Michigan right here. Now you can see it's tilted. This is summer solstice. It's tilted towards the sun. And Michigan hangs over the equator like, let's say 1,000 miles roughly.
What?
Now in the wintertime, we're going to flip it around the other way. Okay, now Michigan is going to be right here, basically. It's going to be, let's say, 3,000 miles in. So there's a difference of like 4,000 miles between winter and summer as far as the distance of the sun goes.
I don't think it works quite like that.
Now let's look at the distance to the sun. The sun is 93 million miles away, and at a 4,000 mile difference, take 4,000 divided by 93 million, and you get 0.00004, which is really, heat-wise, I imagine it would be negligible.
Yeah. A bit like your IQ.
Okay, let's tilt the globe away from the sun. Now, one of the ways we can get an idea is let's say we'll take the coldest day in the wintertime at noon, and then we're going to compare it to, move this back to summertime. We're going to compare it to morning. Here's Michigan. We're going to compare that to morning in the summertime and see what the temperature difference is to see if our angle makes a difference or not.
Compress the data. I've got to smuggle it to NASA. Oh. How am I going to smuggle that? Can't you compress it anymore?
Here's our winter, sun shining on the globe in the wintertime model versus summertime.
That's better.
Okay, so here is, I'm going to use a stick right here. I don't know if you can see it. Like there's the middle of Michigan. We're doing Michigan because it's out of 40s. It's at like the 44th parallel. So here's our stick, measuring stick. And let's see what the temperature is.
Anthony, I think we need to disabuse you of some of the misconceptions that you've already been spouting. First of all, you obviously believe that the Earth's orbit around the Sun is a perfect circle, and then you've calculated your rough 4,000 mile difference from the Sun for Michigan between winter and summer. In fact, the Earth does not orbit in a circle, it orbits in an ellipse, a sort of an egg shape for you. In the winter, for the northern hemisphere, the Earth is approximately 91.5 million miles away, and in the summer it's 94.5 million miles away. So let's work out the exact percentage difference. It's almost exactly roughly about 3 and a bit percent. So several million miles difference. So you're going to say, surely we must receive a lot more solar energy when we're closer. We do, about 7%. Excuse me, that's probably Creaky, agent in the field. Hello, Creaky. I presume you've got a report from us. Tell me what you found out.
No, I'm not saying anything.
Oh, thank you. So what I'm interested in is exactly how you are going to experimentally prove that we're wrong.
First, let's touch the 75 degrees at 522. 91. 90. Okay, so let's wait 10 minutes. Okay, we're back. It's probably about 5 minutes went by. I don't know if I got to use a measuring stick every time so you guys can see, but I guess you guys are going to have to trust me a little bit here. Okay, so I'm doing David Weiss's theories. This is winter time. See the angle? This is winter time. Angle and away, 23.4 degrees. Okay, 75 degrees still. 5 minutes later. There's Michigan. Right there.
Anthony, let me make sure that my understanding of your experiment is correct. You have taken a baseline temperature in your garage using a thermometer, getting 75 degrees. You have then carefully used a stick to keep a heat lamp a set distance away from a model globe, and you're measuring the temperature on the surface of that globe in the approximate area of Michigan using a laser thermometer. Am I right so far?
Okay, it's a few minutes later. 75 degrees. 4 minutes later. Okay, let's test Michigan here. Yeah, 92. Almost 93. So it looks like it stopped at 93.
And that's where we are right now, Mr. President.
Sensible. I appreciate you keeping me updated with the investigation. I authorize you to employ the clown music. I am afraid we have no choice.
I think that's probably our only shot, Mr. President. I shall deploy the clown music.
I made a little protractor to line it up with a string to the center of the heat lamp. So when we do summertime, we're going to try to do the same thing. Get up. Now I got it facing towards the globe, towards the sun. And let's check our temperature when you get it set up. Okay, summertime. Let's check our angle over here. So You get the idea. I did it better in real versus on the camera. Actually, I thought the numbers were going to be pretty close to identical. And how can it be that in the morning in the summertime, it's actually cooler than in the wintertime at noon? It doesn't make any sense, right? It's basically the same as wintertime, which doesn't make no sense, which explains the angle doesn't make a difference. The distance makes a difference.
Well, let's take a wild stab in the dark at this, shall we? Which is something you're likely to receive if you carry on with such stupidity. Now, could it possibly be that the reason that your scientific experiment doesn't come up with any sort of sensible results, could it possibly be because, firstly, you have based it on a total lack of understanding of reality, of what science actually has taught us on the subject of the Earth's orbit, its inclination, and the way that seasons work? Could it possibly be to do with the fact that your experiment is shall we say, somewhat vague, using a stick to measure the distance, using a heat lamp in place of the sun, and a model globe in place of the Earth? Could it just be that you're a total and absolute chuff nugget?
Let me show you what does make sense. Standard map of the world, patented 1892. Okay, so here is Michigan, right there. Here's the sun. In the summertime, the sun is close to Michigan. It's making a tight circle. In the wintertime, it's making a farther circle from Michigan. The sun is farther from Michigan, so it's colder. Pretty simple.
Yes, pretty simple. Pretty simply wrong and pretty simply incorrect. I realise that's actually the same thing, but it was such a biggie I thought it was worth mentioning twice. Your flat earth explanation, Anthony, somewhat leaves a lot to be desired. For instance, the explanation of why you can't see the sun all the time, the explanation of what the sun is going around, why it changes from a small circle to a large circle, how it speeds up, how it slows down, and yet always seems to travel at the same speed. Let's have a look at reality. I shall deploy an appropriate level of graphic skill against you. Microsoft Paint. This excellent diagram represents the Earth tilted at 23.4 degrees. At the top, in summertime for the Northern Hemisphere, and at the bottom, the winter time. The black latitude line represents the line that Michigan is on. On the top Earth, summertime, a set amount of solar energy strikes the Earth at the latitude of Michigan, and it is spread over a certain area of the surface of the Earth. When we look at the bottom Earth, wintertime, when the Earth is tilted away from the sun, the latitude that Michigan is on, when it's receiving the same amount of solar energy, that solar energy is spread over a wider area. Plus, of course, the days are shorter. The sun is lower in the sky, and overall it's receiving a lot less energy. That is why it's cold in the winter. Not because Michigan is about 4,000 miles further away from the sun. Anthony, I think that you would have difficulty emptying water out of your shoes if you had full instructions on how to do so written on the heel. Excuse me. Hello?
Sensible.
Mr. President.
Congratulations on averting this disaster by pointing out he has the IQ of the hole in the middle of a donut.
I know. Pretty dumb, isn't he?
Your country thanks you for your service.
Mr. President, the honour is mine.
You may rest your sphincter.
Thank you. Until next time, stay sensible.